Hi, our team was Nirikshak Bot. Our team ID is 497. We are from National Institute of Technology, Calicut. Myself, Abel, leader of the team.
My name is M.K. Atishan.
I am Ajinjay.
I'm John Johnson V.
I work mainly on designing the ball balancing platform, also testing and validating the final code.
My area of focus was to develop the ball tracking algorithm, path planning, communication between the copy sim and remote API, refining the control, and developing the final team run algorithm.
My major contribution was in the role of testing and simulating, particularly with the part of PID.
And my major contributions were mostly in PID design, mesh decoding and generation, the ball traversal, and the final theme run implementation.
We started off with a very basic PID that had its fundamentals rooted in the Ziegler-Nicholas method. But that proved to be a bit time-taking and inaccurate. There were a lot of instances where it overshoot and it lacked a grasp or control at junctions. So we had to modify the skeleton, and there were constant updations and amendments made to reach the final one that we have now. So this going off the basics is absolutely challenging.
One of the major challenges that we overcame was trying to control two balls simultaneously at different platforms. We initially went with multiprocessing, but since this turned out to be too complex and time consuming, we switched to concurrent programming.
One of the biggest learning experience that we had is how to be more patient and not to give up at something.
The positioning of the servos at the adjacent sites along with the support which is provided at the center is enough to make a simple ball balancing platform. And we got this idea from a YouTube video named Acro Ball Balancing Table.
The algorithm sends signals to each fin that tell them to rotate in a certain way. The connections from each fin all the way up to the top plate ensures that the platform inclines in the way it's intended to. The servo fins have opposite orientations to each other. This was done to make the code structure more aesthetically pleasing. Our code is generic enough to support each and every table, the only changes being the table serial numbers like T1 and T2.
In order to make the support at the center, we used two yokes along with a universal joint that were connected by using two revolute joints. We have two servo motors, so it requires 4 servo holders to holding the servo, and each 2 servo holders for each motor. The shaft of the servo motor is connected with the servo fin. The servo fin is then attached with the connecting rod. The other end of the connecting rod is connected with the L connector. The L connector and the connecting rod are joined by spherical joint, and the joint between the servo motor and the servo fin and the connecting rod and the servo fin is revolute. So such a similar connection is made to the other servo also. So thus we completed our ball balancing platform. Thus in total we have used 2 servo motors, 4 servo holders, 2 connecting rod, 2 servo fins, 2 L connector, a base plate, a top plate, 2 yoke, and a universal joint.
So, we are about to start our evaluation for the final theme run. Now, the grader application takes control over the simulation. We can see that all the mazes have been successfully decoded and generated. Now, as the simulation has started, we have the blue ball arriving first. This ball will be navigated to the collection box 1 of the table 2. All the balls travels through table 4, which is a main table. We can also see that the path to the corresponding table has also been drawn successfully. Now, the ball has collided twice at the wall. One of the greatest features that we have introduced is that the ball will only slow down at the turning point if the path is very much straight. Now, the first ball has been transferred to the table 2, where it will be navigated to the collection box 1. We use A-star algorithm for path planning, which uses heuristic to find the shortest path, which also take care of the direction. Now we can see the second blue ball is about to arrive to the table 4. Now we can see that our first ball has collided just when the second ball arrived. This is possibly because we switched our algorithm to a concurrent process so as to support the traversal of the ball on both the tables. During this process, we decrease the differential gain slightly so as to counteract the time delay that is being occurred. in order to execute both the processes concurrently. Tuning the gains in order to support two balls was something that we couldn't achieve with a great accuracy. Now, the second blue ball has completed its traversal on the table 4 and now it is making its way to the collection box 3 of the table 3. Now, the third ball with red color will be navigated to the collection box 3 of table 1. Another interesting aspect that we have introduced is to provide a counteracting torque just when the ball enters a platform. This way, we were able to reduce the collision of the ball at the walls near the downpipe. We have also introduced a tilting algorithm that would incline the table to a maximum possible angle just when the ball reaches the exit point, which would help us in saving time. Now, the fourth ball, which is green in color, will be navigating to collection box 2 of table 3 via the main table.
When a ball leaves the primary table and enters a secondary table, the code simultaneously checks the vision sensor input at the initial conveyor belt for any new balls. If it detects a new ball, the code assumes a special case in which it deals with two balls in different platforms in a concurrent manner.
Now we have the last ball, which is red in color, will be navigating to the collection box 1 of table 1. Another interesting feature that we have introduced is a ball retraction mechanism. By this, we mean that suppose if the table is subjected to some external disturbances or an faulty image frame which causes a ball to drift from its current set point, the ball retraction mechanism retracts the ball to the previous set point from which where it can continue the rest of the path navigation. Now that completes our team run with a total hit penalty of 10